Hey guys, welcome to our lesson for today. Today we are going to look at what we call radical numbers. We are going to simplify them, we are going to add them, and we're going to subtract them. So let's first just start off with some terminology here. This says a radical number is defined as any expression containing a radical symbol. I know we're using the word in its own definition. We're going to talk about what that word radical means in just a second. Okay, so a radical number has to be an expression that contains our radical symbol. Okay, an expression, if you'll remember, that can be numbers, variables, it can have plus signs, minus signs, it could be multiplication, it could be division. It's any kind of combination of numbers and letters. Okay, so for a radical, there are three parts to it. The three parts are called the index. Okay, the index of our radical is this piece right here, this n. So I'm going to go ahead and I'm going to label this line here index. This tells us what root we are taking. So usually this spot is blank, and that means that it's an understood 2, which we call a square root. Sometimes later on in your math classes, you might see a 3 written here. That would be a cube root, a 4, we just call 4th root, 5th root, and so forth from there. Okay, but typically we deal with square roots, which is an understood 2, where the n would be. The next part of our radical is what we call the radicand. So, radicand. Okay, that is the X piece here. It's the piece that's underneath our little symbol here, this little funky looking symbol. We'll figure out what that's called in a minute. Okay, so this here is our radicand. Our radicand can be numbers, it can be numbers and variables, it can be a combination of stuff under here. So it can be pretty much anything. And then the third part is the actual radical symbol. Our radical symbol. And that's the funky looking thing that kind of looks like a check mark with an extra line. So that is called our radical symbol. If you see a radical symbol, then that means you have a radical number. Okay, a radical number consists of your index, which tells you which root you're taking. The radicand is what you're taking the root of, and the symbol tells us that we are actually taking that root. Okay, so the next part underneath here, it says the blank shown as n above. Well, we said the n piece was the index, so this is index, is always a positive integer. It will always be a positive integer. This sets our power, or what we call our root. Okay, I'm going to put root in parentheses because sometimes we call it a root, not a power. Okay, so we're looking at that number. We're taking the second root, the third root, the fourth root, etc. The blank shown as the x above, so we said the x was called our radicand. Our radicand can be any number if n, which we said is the index, is odd. So it can be any number, positive or negative. That's what I mean when I say any number. It could be positive or negative, as long as that index, this number outside here, the little number, is odd. But if your n is even, then your radicand must be positive. Okay, so if the radicand, okay, so your radicand is the number under, so if that's positive, then we could take an odd root or an even root. Okay, if it's negative, this outside would have to be an odd root in order to take it. Okay, and then that third dot down there at the bottom, or that last dot, I should say, if n is not shown, then n is an understood 2, and we call that a square root. This is the one that we will be dealing with in Algebra 1, a square root. All right, so let's scroll down a little bit. And let's actually start to take the square root. Now, for this unit, we are not using a calculator. So that means we need to be familiar with these numbers and how to break them down and so forth without having a calculator on hand. Okay, so we're going to do that. We're going to talk about how to simplify our radicals. Okay, in order to simplify a radical, we must have a pair. Okay, so thinking about a pair, that means you have to have 2 of them. 2 things that are exactly the same. So think about if you're playing match, you have to make pairs. That's 2 that are exactly the same. Okay, so we need to find 2 numbers in this number 25 that are exactly the same. Well, what we want to do is we need to break down this 25. So I like to use, okay, this is called prime factorization, and I use the upside down ladder method. Okay, you might call it something else. It basically looks like a division, but upside down. Okay, so I'm going to say what prime number goes into 25. So a prime number would be 5. Okay, so if we need to think through our prime numbers, that's 1, 2, 1, 2, 3, 5, 7, 9, 11, 13. These are typically the ones that we're going to see the most. Okay, these are prime because the only number that goes into them is 1 in itself. So I didn't use a 4 because 2 goes into 4. So 4 is not prime. But we do see that 5 is prime. So 5 goes into 25 5 times. And once this number is prime, then we're done. So we can rewrite the square root of 25 as 5 times 5. Well, that is a pair of 5s. That means that together they come out as one set of 5s. Okay, well, you guys could have thought through and said, hey, 25 is the perfect square of 5 times 5, so it would be 5. Likewise, let's look at 64. So we take 64 and let's break it down into its prime factors. Okay, when I look at this, the first number I think of that's prime that goes into 64 is 2. So 2 goes into the 6 3 times. We're just really doing division here. And then 2 goes into 4 twice. 32 is not prime because it's even, so I'm going to do this again. 2 goes into 3 once with a 1 left over, so I'm going to put it there. So now I'm doing 2 into 12, which is 6. 16 is not prime, so we're going to do it again. 2 goes into 16 8 times. 2 goes into 8 4 times. And 2 goes into 4 twice. So really, the square root of 64 is 1, 2, 3, 4, 5, 6 2's being multiplied together. So 1, 2, 3, 4, 5, 6. So that means we have 1 pair, 2 pairs, 3 pairs of 2's. So 3 pairs of 2's means that I have 1 pair of 2's. I'm going to multiply it with a second pair of 2's and multiply it by a third pair of 2's. Well, 2 times 2 is 4. 4 times 2 is 8. We could have thought through and said, hey, 64 is 8 times 8, which is 2 pairs of 8. 8, 16, 24, 32, 40, Lord, 48, 56, 64. So 8 times 8 is 64. So that is one of our perfect squares. And it's helpful if you know your perfect squares. Okay. So let's try these ones. These ones are not going to be perfect like the last ones. We're going to have leftovers. So let's see what these look like when we have leftovers. So we're going to start with 75, and we're going to break down our prime factorizations. Okay, so I think 5 is a good prime number that's going to go in, and I know because it's a number that ends in 5. So 5 goes into 7 once with 2 left over. So now I'm saying 5 goes into 25 5 times. 15 is not prime, but let's try 5 again. 5 goes into 15 3 times. 3 is prime, so that means 75 breaks down into 5 times 5 times 3. Here we see we have one pair of 5s, so we bring the pair of 5s out, and then that 3 didn't have a pair, so it stays underneath our radical. Okay, we're going to try another one, 180, the square root of 180. So I'll do that over here, give myself a little bit more room. Okay, this is a number that ends in a 0, so we know that it's even, so a 2 will go into it, but we also know that a 5 will go into it. So I'm going to do 5 because that's bigger. That's going to help me get to the numbers I need quicker. So 5 goes into 18, so that goes in 3 times. That's actually 15, so that gives us a 3 left over. 5 goes into 30, 6 times. Okay, 36, you can either use a 2 or a 3. It's your choice. I'm going to do a 3. 3 goes into 3 once. 3 goes into 6 twice. I'm going to do a 3 again. 3 goes into 12 4 times. 2 goes into 4 twice. So 180, the square root of 180 can be broken down into 5 times 3 times 3 times 2 times 2. So we're looking for our pairs. We have a pair of 3s and a pair of 2s. All right, so I have a pair of 3s that come out. We multiply it by the pair of 2s that come out. And then the 5 didn't have a pair, so it stays under. So just multiply our numbers. So 3 times 2 is 6, square root 5. Okay, go ahead, pause this video, try the next ones there, 5, 6, 7, and 8, and then check your answers. Okay, so let's look. Number 5 is 4 square roots of 3. Number 6 is 12. I like to use the numbers that I put over here on the right-hand side to help me get my perfect squares. So we know that 144 is the perfect square of 12. Okay, so if you don't know these, they're good to memorize. Number 7 ends up being 8 square roots of 3. And number 8 ends up just being the square root of 38. There are no perfect squares or no pairs when you break down 38. Okay, if we look at number 9, you'll see that I already have this one written out. The only thing that changes when we add variables is that we need to write out the variable part. So 25 breaks down into 5 times 5, and x squared is just x times x. So we break everything down the same way we have, and we find the pairs. Okay, so for like number 11, we know that 175 breaks down into 5 times 5 times 7, okay? And then we have 4 x's and we have 3 y's. So we're just looking for our pairs, and we get that we have a pair of 5s, 2 pairs of x's, 1 pair of y's, and then we have a 7 and a y left over. Okay, so try the next two. Here's your answers.